Welcome to Module 3, Lesson 6. We are going over ellipse. So to prepare for this lesson, you do need to be familiar with circles. We're going to compare circles and ellipse formulas here in a second. And you're going to see that they're very, very similar. So if you understand circles, it definitely helps understanding ellipse. And then you also need to know how to complete the square. At the end of this lesson, we're going to be taking equations in general form and putting them into a different form. And so we need to know how to complete the square in order to do that. Our learning objectives is to analyze and graph ellipses when they are at the center or when the center is at the origin and when the center is shifted to an HK, so somewhere other than the origin. And then as always, a general learning objective for all conics is to know the general form of the equations of conic sections, understanding how the constants of the equations relate to the graph. And that comes kind of back to completing the square. Guessing you've already used this QR code, which you can pause and rewind as often as you need. So this lecture is at your own pace. And then look at your course schedule to see when this lesson's homework is due. So before we get into our lesson, which we will start on this page in this video, I just want to take a moment, and this is how I always do it when classes are on campus and I'm teaching, and it is to compare our two formulas for circle and ellipse. So I would suggest that you guys take a moment and pause this video and tell me what similarities are between these two equations and also what is different. Okay, I hope you had time to pause the video. So there's really kind of one big similarity, and it's that both of these have that x plus h quantity squared, y minus k quantity squared. So you have that here, and also here and here. What's different is kind of two things, but they kind of correlate with each other. In a circle, this always equals the radius squared. And this can equal the radius squared because remember that radius means that it's equal distance from the center to anywhere on that outer edge of a circle. So it's always the same, it's constant. Here, these equations are going to equal 1 because now that I have an ellipse, it's kind of like an elongated circle or an oval. It's not going to be equal distance from that center, right? We're either going to stretch this horizontally, which means my major axis is parallel to the x-axis, or we're going to stretch it vertically, meaning my major axis is parallel to the y. And so when that happens, we're going to be dividing these by an a squared and a b squared, and those are going to alternate, and that's going to tell us something different about those ellipses. So a lot of similarities as far as where the center is. Circles equal an r squared, ellipses equal 1, and now we're also dividing by an a squared and a b squared. So coming back into our notes here. I want to make sure I was recording. Coming back into our notes, let's kind of start again by the definition. And then we're going to talk about it and talk about some key things when we're graphing it. So your definition of ellipse, and it's really kind of a, I don't know, a janky definition, but it is what it is. It's the collection of all points in a plane, the sum of whose distance from two fixed points called the foci are a constant. So this foci, which are these F1 and F2, are part of that definition. So it's not important when it comes to the shape of this, but because it's part of the definition, and more specifically, because your Mind Math Lab is going to ask for it, we are going to cover it and plot them. Now, when it goes on to say that the sum of whose distances from two fixed points called the foci is a constant, what that means is, and they've kind of illustrated here on this ellipse, they have used their little pencil here and they have put a random point on this ellipse. If I call the distance from my focus 1 to my point, D1, And if I call the distance from my point to my second focus B2, no matter where this point is on this graph, when I add up those distances from my focus 1 to that point and from that point to my second focus, it is always going to be at a constant of 2a. Now we're going to explore what this means in a little bit further in the lesson, but let's kind of keep that in mind, that that's kind of that relationship and why this focus are so unique. So when it comes to graphing, we are going to need to plot every time 7 points. So the first thing we need to plot is the center. And I'm going to abbreviate that on my graph as C. You can see right here, C is here in the middle. So we technically have 4 different vertices. My math lab and this book really only emphasize 2 of them. Whichever way that this is elongated is considered your major axis. And on that major axis, we have 2 vertices here, and these are considered your major vertices, and we have 2 of them. So on these right here, we're going to abbreviate those with a capital MV. These are our major vertices. So when they say vertices, that's all they care about are these 2 right here. You can see here, they don't even put points on that minor axis. But on that minor axis, which is the shorter side, lie your 2 minor vertices that we're going to abbreviate with a lowercase m. So I'm going to go ahead and put a point there as well. We have lowercase mv for our 2 minors. And then lastly, we need to put our 2 foci. So we'll have the center, essentially our 4 vertices, our 2 major, our 2 minor, and then the 2 foci right here. So as we get into our formulas, which was on the next page, and we'll go over in the next video, here's kind of what we are looking for. So this is how we're abbreviating everything in our graph. But when it comes to the formula, we need to be finding A, B, and C. Now we're always going to be given A, and A is the distance from the center to the major vertices. We will always have A in some capacity. Then we will either be given B or C, and we're going to have to find the other one. B represents the distance from the center to the minor vertices. And then C is the distance from the center to the foci. Okay, so coming back up here to this, if A, the distance from my center to my major vertices is, let's say, 5. From center to major, we would go 5 units, and then we'd go 5 units this other way. So this entire thing here would then be 10. Then if B, my distance from my center to my minor vertex is, let's say, 3, we would go from center 3 in one direction, 3 to the other. So the entire thing would be 6. And then C is the distance from my center to my foci. So maybe the center to your focus is 4, and we go 4 the other direction. The entire thing would be 8. So my A, B, and C tell me kind of the distances from the center to major, minor, and foci, and that's going to help me graph these. So that was a really long introductory video, but now we hopefully know a little bit more about ellipses. So in the next video, we're going to start working through those formulas.